Let's try to get that out of the way. Oops. There we go. All right, so we're back. Sorry, there are 8 seconds of me trying to move something on the screen. And we're going to finish this lesson. And guess what? We're going to the next one.
Yay!
So when we come back on Monday, the 4 of us are going to say, we're all done.
Woo!
All right, well, except for integration by parts. But integration by parts we're going to do
And we have
after.
We have to do the stupid slope fields.
Yeah, that we're going to do.
That too.
All right, so find the volume of the solid generated by revolving the region bounded by the given lines and curves about the x-axis. So it's about a horizontal line, so it is dx. So horizontal line's dx. So revolving around y equals 2, revolving around the x-axis, it's dx. If I revolve around a vertical line, it's dy. All right, so the cross-section area is just the the area of the circle created by the outer radius minus the area of the circle created by the inner radius. I always graph these first, so I have 2 lines here. I have the line y equals 2x, and I have the line y equals x. And when you rotate those triangles around, it creates like a kind of like a cool kind of bowl with a very pointy bottom. So maybe it's a lampshade. If you turn your head around.
Picture of drunk people in it? I'm sorry.
It's a lampshade. So it's a very beautiful lampshade, I think. Anyway, so we need our limits of integration. First of all, we have the line x equals 1. That would be one of our limits of integration. And then if we set the 2 functions equal to one another, well, they intersect at 0, 0. So that would be the other one. All right, so our limits of integration are going to be from 0 to 1. All right, so to get the volume, right, we just integrate the cross-section area. So we have pi times the integral from 0 to 1, 2x squared minus x squared dx. So that gives us 4x squared minus x squared dx. We may as well simplify that to 3x squared dx. So then you just integrate. So that would be x, it would be, well, there was a 3 there. So it would be 3x cubed divided by 3, which is x cubed, evaluated from 0 to 1. And that's just going to give us 1 pi after we do the substitution. So the volume of our solid here is 1 pi. So the red function, the red lines are the actual function. The green is the mirror image because it's rotating around x. Just makes it look a little bit more solid.
Is that a pun?
Yeah.
That's fun. It's a great pun.
What's that expression? Do me a solid?
What?
I did you a solid.
Oh gosh. Okay. Thumbs up to you. I think my brain just, cracked a little bit. Just kidding.
Brains can't crack.
People's here, let me know if I go by too quickly and you don't get a chance to take notes.
Have you ever touched a brain before?
Yes.
I touched
Isn't
the
it
cow's
cool?
iris.
I was at the bodies exhibit. That was really cool.
Dissected a person. Now that's on tape.
Ooh, that's fun.
Are you serious?
You dissected a person?
Mm-hmm.
That's so awesome.
That is
Why don't you do
awesome.
that?
Can we do that?
No, you cannot.
But it sounds
You are not
fun.
trained
Wait,
Were you an EMT or something?
in anatomy, studying medical.
Oh, that's cool.
Can I take an anatomy class without going for that as my degree? Like an extra class? That sounds
It's a lot.
Russell, what about
You're
manually?
not.
Yeah.
I wanted
You have to yield a scalpel.
Oh god.
I can do that.
But is
I wanted to
manual
just
labor-
get the train to become an EMT in college and do that as like a job.
Mhm.
I think that'd be cool.
Touch.
Does Syracuse have like on campus ambulances and stuff? Because I know some schools do.
Maybe.
Sort of.
I'm losing myself. I'm just kidding. We're not really at it anyway.
So we're going to do a couple more examples in here. So hopefully you guys don't, I forgot to say, take out your notes. You can take notes on this and fill in my notes because I didn't put the work in yours.
What is in front of the pie?
Front of the pi is the word V. V is?
Yeah, V equals pi.
V equals 1 pi?
Yeah.
Yes, V equals 1 pi.
Okay. So I can just put pi in it.
You put pi, yeah. I just wanted to make
was
sure
just like-
it was clear that it was 1 pi.
If
don't know
we took
why.
the time on like an FRQ or something to actually draw a pi and say 1 pi, would they accept it as a joke? and like give us the points? Like,
No.
Do you think the reader would have a sense of humor?
No, but there's been like really stupid answers.
Oh.
That
From-
probably made them laugh a little bit.
No, that just annoyed the heck out of them.
Oh. So what if every time you wrote pie, you put it in a little pie jar?
What's a pie
I'm
jar?
sorry. Okay. You draw a pie, and then you put the symbol pie inside of the pie, so it's still pie. It's
I
different,
guess.
But you have a pie around it.
Oh, did you need me to go back?
I didn't mean a pie jar. Ooh, looks like an eyeball.
It does, doesn't it?
Yeah, it does.
All right, so here the function that's being rotated is 4 minus x squared. So that's the red, and the 2 minus x is the green. And so then the blue is the mirror image there. All right, so it rotates around, and it almost looks like a tulip shape, doesn't it? All right, so the area of my washer, this could look neater, couldn't it? The area of the washer is pi times the outer function squared minus the inner function squared. And there actually should be another set of parentheses around this. Yeah, I'll write that better. That just looks really bad.
So everything that's squared by?
No, but everything's multiplied by pi. So our cross-section area is pi times the outer radius squared minus the inner radius squared. There we go. All right, and so once we, how many parentheses in this? Once we integrate that, then we have the volume, okay, not just the cross-section areas. All right, so our outer radius, the parabola is the outer function. We are rotating around the x-axis here, so that is on the outside. It's creating the outside of the washer, and then the hole in the washer is being created by the line 2 minus x. All right, so our integral will be it'll be 4 minus x squared, the outer function, all squared, and then minus the inner function 2 minus x all squared. That is a dx. Right? And so for our limits, you just set the functions equal to 0. So 4 minus x squared equals 2 minus x. And just move everything over. So yeah, 0 equals x squared minus x minus 2, and which factors into x minus 2 times x plus 1. So our two solutions are 2 and negative 1. So those are our limits of integration here. Kind of looks like a 7 instead of a 1. Negative 1. All right, so here we had a square first. So 4 minus x squared all squared is 16 minus x squared plus x to the 4th. 2 minus x all squared is 4. That's a plus 14, plus 4. Kind of looks like a, I don't know. Looks like a minus 4, and it looks like a 14. It was 4. Yeah, 4 plus 4x plus. Why do I have a negative 2 on that thing? It's supposed to just be x squared. I don't know. I think there's a random negative number. Yeah. Nowhere else does that appear. I don't know. There's a little line on there. It's x squared. All right. So, yeah, I know where that came from. I was moving things around, and so I got a negative on there. All right. So then we combine our like terms. There, distribute the negative. Oh, I know what I was doing. I was distributing the negative. That's why that was there. So we would have a negative 4, a negative 4x, and a negative x to the negative x squared. So 16 minus 4 gives us 12. A negative 8x squared minus an x squared gives us a negative 9x squared. And then we have an x to the 4th and a 4x. Okay. So you integrate, and you get 12x minus 3x cubed. It'd be 9x cubed divided by 3, so that's 3x cubed. And then 5x plus x to the 5th divided by 5. And then we'd have 4x squared divided by 2, and that reduces to 2x squared. And then we'll just plug in our values. So we've got volume is pi. There really should be parentheses here.
Yeah.
So it's pi times 12 times 2. Because we're integrating from 2 to negative 1. There we go. So there we go, so we can see it. So we have 12 times 2 minus 3 times 2 cubed plus 2 to the fifth divided by 5 plus 2 squared times 2 would give, and then minus, there we got to integrate a value from -1. So 12 minus -1 and minus 3 times -1 cubed plus -1 to the fifth divided by 5 plus 2 times -1 squared. So once you raise all of the powers and you add and you subtract and you combine all the numbers together and then you multiply by pi, you get 108 pi is our volume.
Why did we plug in? Oh.
Because our limits of integration were from -1 to 2.
Oh, that's the whole thing. Man. Okay.
My mom wants to have a no an ETA. It's not saying it's like when will be done. About I said 3 to 4, but
Whatever you want to do.
never.
There you go. That's Russell. It's got
There
no way.
you go. Just kidding.
Angie, stop trying to pick out my puns.
This is our
It's not funny anymore. I'm just kidding. Oh
That was
gosh.
punishment.
Oh my gosh, Langie.
I don't think so.
Okay.
It-
Has it? I've never
yeah,
seen it
it's
before.
been extremely. Is it 2 to the cube? Power? Yeah, right? On v pi 12 times 2 minus 3.
Yeah,
Cube. Okay.
yeah.
Almost
Oh,
there.
maybe it does. What? Oh, I see what.
So this is just all the same crap. You just do the outside.
That's a nice way to put it, Russell.
Thanks.
The outside function minus the inside function.
Yes.
Okay.
But you have to remember which is, well,
You have to know what x or y, which direction.
yeah, and you know what you're creating here. But yes.
It's
Wait, how does the 16 turn into a 12 and the 8 turn into a 9?
We combine the 16 with the -4 and the -8x with the -x.
Oh, okay.
Because they would have distributed.
You squared the functions out and then took the integral.
Yes, you did need to do that. Yeah, you do need to square the functions and then take the integral because you will not be able to do u to u substitution.
Oh, okay.
Yeah, that's
So yeah, you're going to have to square.
So we did you use it?
No. You can't do u to u substitution here.
X
Not for the squaring part of it. So you can't put the square on it and then expect to do the u to u substitution. You won't find the derivative. So yeah, you do have to, and the derivative is not going to be just a constant term. So yeah, you do have to do the squaring.
And the lower function is a 2 minus x, right?
Yes.
Okay. Cool.
Baghdad in a state of emergency after supporters of al-Sadir storm green zone.
Okay, got it.
Oh
Sorry.
no. It's okay. So people at home, you could be taking notes while people here are taking notes. So you don't even have to pause the tape. You can take notes at the same time. Pretty cool.
Me session. Is it unlocked?
No, you have to go to the kindergarten ones. Yeah, it sucks.
Why do the kindergarten ones are unlocked?
I don't know. Maybe they just don't think people are going to break in. Oh no, break in.
break into a
is
bathroom
bad.
do what?
What?
What are you gonna do?
It was always unlocked.
Really, Langie? Wait, is that
What?
does that move over to the next second line?
Which one?
The last one?
Yeah, you mean minus 12 times -1 minus...
Yeah, that goes
Yeah.
Right.
Yeah. That's all just part of the same thing. I just ran out of space, so I had to move down to another line. And then rather than writing all these things out, 24 minus, so it would be minus 16, minus 48, and then plus 32 fifths, plus 8, and then plus 12, and that would be a minus, because that'd be 3 negatives there, that'd be a minus 3, and a plus 1 fifth, and a minus 2. I just gave you the answer, which is 108 pi fifths. And so we want to determine the volume of a solid generated by rotating the region bound by y equals the square root of x and y equals x divided by 4, or 1/4 x, that lies in the first quadrant about the y-axis. So step 1 is to graph the bounding region and graph of the object. The cross section is cut perpendicular to the axis of rotation, so it's a horizontal washer. the inner and outer of the washer, inner and outer radii of the washer x values. So we need to rewrite our function in the form of x equals. So we're rotating around a vertical line. It needs to be x equals, right? So no problem. So the one we have y equals x cubed. So if you cube both sides, I don't know if I put it in here anywhere, but if we cube both sides, so if y equals the cube root of x, and we cube, we have y cubed equals x. And there's only one solution for that because it's an odd number. And then if y equals x divided by 4 and multiply both sides by 4, 4y equals x. So those are our two lines that are graphed. 4y equals x and y equals x equals y cubed. All right, so the outer function is x equals 4y. The line is the outer, and the y equals x equals y cubed is the inner function. So we need to solve for x. Let's rewrite that to find our values. And I think I have it over there. Okay, so we have I'll add that what I had in there, but I'll write it neater. So we have a vertical axis for revolution there, revolving around a vertical line. And if we set our functions equal to find our limits of integration, we get y cubed equals 4y. So plot a y, and you've got y squared minus 4, which we could factor. And that would be 2 and negative 2, except it has to be in the first quadrant. So there is one more solution, y equals negative 2, but he's no good because it's the first quadrant. And so he's eliminated. So 0 to 2 are the y values. Make sure when you're integrating with respect to y, it's y values or your limits of integration, not x values. Gotta be careful on that. All right, so the area of our washer is formed by the outer radius squared minus the inner radius squared. So the outer is the 4y squared, and then the inner would be the y cubed squared. And when we square, we get,
Can you scroll down?
yeah. And we're going to scroll down. Did I ever, I don't know if I ever squared. I'm going to redo this problem. I can't see that I squared. All right, so I'm going to redo that. All right, so we've got, it was the integral, the outside was 4y, or maybe I did, but I have to square all of it, so something seemed wrong. So 4y pi.
You square it first, right? And then you integrate?
Yeah, and I don't see that I squared it. So I'm going to just redo all of this. All right, so we have 4y all squared minus, and so this is our volume, right? And minus the, what is it? The inner is the y cubed. Minus y cubed all squared dy. And we're integrating that from 0 to 2. Right, so our volume is going to be, let's square first. So this would be 16y squared minus y to the 6 dy. Right? And then we'd integrate. So our volume is pi times 16y cubed divided by 3 minus y to the 7th divided by 7th, all from 2 to 0. All right, so now we'll plug in, and we've got our volume is pi times 16 times 2 cubed divided by 3 minus 2 to the 7th divided by 7th, and then it would be minus 0, right? All right, so that would be 16 times 8, because 2 cubed is 8, would give us 128?
Yes.
Okay.
16 times 4 is 64.
So 128 thirds minus 2 to the 7th would be 128 sevenths. And then we just got to change that so we can. So if you multiply by 7, that's going to give us 128 times 7. Oh, I do everything in my head.
896.
896. 896 21st. And 128 times 3.
256. 3.
Just doing the calculator.
80.
Such a faster.
246.
People are waiting. 246?
Wait, no, wait. Okay, what is it? Okay, 128 times 3.
Yeah.
Okay.
384.
Thank you.
That's what I was gonna say. I did say 84. You heard me say 84. I was almost done, Miss Michelle.
So if we subtract, we've got 512. So 512 pi 21st. And that would be our volume. Okay. Be real careful to square the 4 there. So you're squaring all of the function. I'm not sure I had the 4 squared. So I rewrote it. So now it's all good.
Like the game Foursquare?
Yeah.
Sorry.
I wish we could do class outside. It's so nice out.
It's hot. It's
That's
sunny.
I was just out there. It's like, it's windy. It's nice. It's
But it's
overcast.
sunny.
No, it's not. It's
That's
over.
right. I have to wear my sunglasses to
Me too.
look outside.
How can I do class outside? How can we record this
Yeah,
outside?
technology, bro.
No, we sit on the table. You have the computer and you teach like that. And forget these kids. You guys suck.
Forget you. Just kidding.
It's going to be on my tape, dude.
That's okay.
If they're fine, they know they suck.
Stop it.
It's at 22 minutes if you want to stop.
Oh, let me see how much. So we're almost done. Let's see. We got 1, 2, 3. Okay, yeah. We'll
We'll cut that tape.
stop the tape.
Bye.
Bye.